Hi everyone. Today let's talk about section 1.4, Arguments and Rules of Inference. Arguments. Consider the statements. John is a logical person or is outside. John cannot do logical things. What can you conclude? An argument is just a series of propositions written like this. Okay, so we have a bunch of propositions, and so the propositions P1 to Pn are called hypotheses or premises. P is called the conclusion. Okay, so all these are called hypotheses. Okay, or premises. And then P is called the conclusion. All right. Note that an argument is considered valid if the truth of the hypothesis, the premises, mandates the truth of the conclusion. To be valid, an argument does not have to be true, nor do any of the hypotheses has to be true. The conclusion has to be considered true if we assume the truth of the hypothesis. Okay? If the truth of the hypothesis do not mandate the truth of the conclusion, then the argument is considered invalid, a fallacy. Okay? So let's look at some examples. If it rains outside, then the sidewalk will be wet. It is raining. Okay. So here, what do we have? If it rains outside, then the sidewalk will be wet. So this is Q. So the first sentence is like P implies Q. And then the next line, it is raining. So that's the P. So conclusion, because P implies Q, and now P is happening, so therefore Q is happening. So the sidewalk is wet. Okay? And this is what it means. Next, if the sky is blue, then it is raining. Okay? So in this case, P is the sky is blue, it is raining, is a Q. Okay? So P implies Q. If the sky is blue, so the sky is blue, this will imply it is raining. So guys, so far so good? Okay. And by the way, here, this sentence, P implies Q, according to this sentence, we can write this argument. But that's not necessarily saying that the hypothesis must be true or the conclusions is true. So if the hypothesis is true, then the conclusion will follow. Okay? Next, if John is running, then he is exercising. Okay, so P is John is running, then Q is he's exercising. So if John is running, okay, that's the hypothesis. Then the conclusion, so he is exercising. This is the simplest case. P implies Q. We have one hypothesis and we have one conclusion. Okay? An argument can be more complicated than that. So here are the rules of inference. Okay? So what we just learned, P implies Q. If P, then the conclusion is Q. This is called modulus ponens. Okay, modulus ponens. So you talk about, okay, P implies Q, P happens, so Q is also happening. Okay, so next, P implies Q, not Q, so not P. Do you remember P implies Q is logical equivalent to not Q implies not P? This is the contrapositive. Okay, so that's why not Q is true. That implies not P. Okay, and this is called modus tollens. Okay, actually it's modus tollens. Okay, typo here. Next. So modus tollens is P implies Q. We have P, so Q. Modus tollens is the contrapositive. We have P implies Q, but we have not Q, so the conclusion is not P. Next, P. So this 3 dots is so, therefore, hence. Okay, it means that. So P, therefore, P or Q. Okay, if P is true, then P or Q is true. So this is addition. Okay. Next, if P and Q is true, then Q is true. Okay, so this is simplification. So yeah, remember if P and Q both happens, then P must happen, right? So this is simplification. Next, P happens, Q happens, implies P and Q happens. This is conjunction. Okay? Next, P implies Q, Q implies R, therefore P implies R. So if we put the arrows here, P implies Q, Q implies R, so P implies R. Okay, this is we have a shortcut here. Okay, this is called hypothetical syllogism. Okay, hypothetical syllogism. Next, P or Q, but not P. Oh, it must be Q. Okay, so P or Q, not P, then must be Q. So it's okay, what do you want to eat for breakfast? We have orange or apple. So you must eat something, okay? Your mom asks you to eat it. Then if you don't eat apple, then you have to eat orange. This is what we have, okay? So P or Q, not P, then Q. So the conclusion is Q. This is called disjunctive syllogism. Okay, so yeah, we need to remember the names because in our examples next page, when we figure out the rule, we have to say what rule we are using. Okay, let's continue. Okay, P implies Q, therefore not Q implies not P. Oh, this is exactly the contrapositive equivalence. Okay, not P. Not P is P. So this is the not equivalence. P if and only if Q. Well, P if and only if Q. This is the same as P implies Q and Q implies P, right? So that's why we have P implies Q, or we can have Q implies P. This is definition of biconditional. Okay, so those are all the rules of inference. Let's do more exercise. We write in symbolic form. Determine whether the argument is valid. P, I study hard. Q, I get A's. R, I get rich. If I study hard, then I get 8s. I study hard, so I get 8s. Let's see. If I study hard is P, so P implies I get 8s. Q, I study hard, that's the P. Therefore, we have the Q. Is this valid? Yes. This is P implies Q, and then so we have P, therefore Q is happening. This is modus tollens. Okay, modus tollens. Next, if I study hard, then I get 8. Study hard, P, then I get 8, Q. If I don't get rich, so not R. then I don't get 8. So not Q. So I get reach. Okay, so let's see. Okay, is this a valid statement? Okay, let's see. P implies Q. So not R implies not Q. Well, this guy, I don't want to use the arrow. Arrow is really the implication, okay? So this guy is equivalent to the contrapositive, which is Q implies R, right? So we have P implies Q, Q implies R, therefore R. I would say this is invalid. Okay, because we don't know whether the P is true or Q is true, so we cannot imply R. However, I want you to see the difference between I'm gonna write here. So if the argument is P implies Q and not R implies not Q, therefore P implies R. So if you have this argument, this is valid. Okay? Yes, this is valid because P implies Q, not R implies not Q. Well, this is the same as Q implies R, so P implies Q, Q implies R, therefore P implies R. This is hypothetical syllogism. Okay? This is I miss an O. Hypothetical. Okay. Hypothetical syllogism. All right. Next. Yes. So I also want to put it down how to make this guy valid. Okay. So this is one example, and let me use another color to indicate. How about purple? So if we have P implies Q and we have not R implies not Q, and if we have P, then therefore R. So this guy is valid. Okay. Yes, because from let me see. Why this is valid, we can actually show it here. So why this is valid, let me show it here. Okay. So 1 and 3 implies Q. So we number the lines. 4, we get Q from 1 and 3. Okay, P implies Q and P is true. So this is using Models Poland. And then because we have from the line number 4 and number 2, not R implies not Q, and we have Q. Because not R implies not Q, this is the contrapositive is Q implies R. So and Q is true, so we have R is true. So this is Models Poland. Okay. Yes. So therefore we get our conclusion R. So now we have shown why this statement is valid. So far, so good, everybody? All right, let's continue. I also want to give you one more example that is not valid. Okay, let me put it here. So this is a not, oh, is it blue? Let me see. This is not valid example. Another not valid example. Okay, so it's if 2 equals 3, then I ate my hat. Okay, I ate my hat. So 2 equals 3. Okay, so what is this guy? Let's call P to be 2 equals 3. I ate my hat. Let's call this as Q. Well, this statement, if we use the symbol to represent, it means P implies Q, and then I eat my hat, Q. Therefore, P, and this is invalid. P implies Q. Knowing Q tells us nothing about the P. Okay, if we know P occurs, then we can say Q also occurs. But if Q occurs, then it tells us nothing about the P. Okay, so this is another example of invalid. Okay, so there are 2 ways of proving the validity. First, using the rules of inference, like what we did. Okay, put it into the lines and then use different rules of inference. Also mention the names when you use them. Okay, and second, use a truth table. Okay, so let's look at the following example. Which rule of inference is being used? First, baseball is popular. Okay, let me change my color back to orange. Baseball is popular. Let's call it P. Therefore, baseball is popular, or soccer is popular. So we have P here, and then therefore the 3 dots there. Okay, the 3 dots. Baseball is popular, P, or. Okay, so or looks like the V, right? Soccer is popular, Q. So P, and then so P or Q, and this is valid, right? This is actually the rule is addition. Okay? P occurs implies P or Q occurs, right? Okay, next. Tom is a tall man. Okay, Tom is a tall man. Or the sky is blue. So this is P or Q, right? The sky is not blue, so not Q. Therefore, Tom, can I move it? Okay. I ran out of space. So therefore, Tom is tall. So therefore, P. Okay, is this valid? Either P, so P or Q, but not Q, it must be P, and this is valid. And then what is this guy? This is the disjunctive syllogism. Okay, so I have apple or orange for you. If you don't like apple, you gotta eat orange. Disjunctive syllogism. So syllogism. Okay, let's continue. The weather is cold outside. So let this be P. And it is really warm out. Therefore, it's really warm out. So P and Q. Okay, therefore, it's really warm out Q. Okay, is this true? So P and Q happen. So Q happened. This is valid. And this is simplification. Yes, if P and Q are happening, then Q is happening. Okay, this is simplification. So far, so good, everybody. Yeah, so keep in mind the names of different rules of inference. Okay, so let me review with you. Modus ponens, P implies Q, P is true, so Q is true. Modus tollens, P implies Q, but not Q, so not P. Addition, P, so P or Q. Simplification, P and Q, so P. Conjunction, we have P and we have Q, so we have P and Q. Hypothetical syllogism, P implies Q, Q implies R, so P implies R. Disjunctive syllogism, P or Q, but not P, so Q. Okay. And we have the contrapositive, not equivalence, the biconditional propositions. Okay, good. Next example. Give an argument using rules of inference to show that the conclusion follows from the hypothesis. Okay, now let's see. Let's call this, so this is a longer proof. So let's put the lines there. We have line 1, line 2, line 3. Okay, so how do we get R? So first of all, using 2 and 3. Okay, this is quite long, so let's don't look at the first line. Let's look at the second line and third line. We have S and T and not T. So you can see we can say something about S. Okay, so S implies T. So this is line 4. S implies T, but not T. Remember, not S implies T. The contrapositive is not T implies not S. So not T is happening, therefore not S. And this is from the line 2 and 3. And we are using what rule? We're using modus tollens. Okay, everybody? All right, let's continue. And then not S. So you can see we're getting close because not S, we have this guy. So not S. What do we say? Okay. Let's see. Not S. Because here we have S, we don't really have not S. So, and here, S and T, not S and L. So not S cannot tell us anything. So let's change this. Okay, so let's change number 1. So let's call this 5, and let's consider the contrapositive of number 1. So this is not S and L, implies not R or not F. Okay, so here we're using, let me move these to the right so I can have more space. Okay. All right. Okay, let's see here. So this is contrapositive, right? This is from number 1, and we use contrapositive. All right, next. Well, how do we move the not inside the parentheses? We use De Morgan's law. So not S and L is not S. Flip the and an or. So it was and, now become or. Not L. Okay. Implies here we're gonna have not R. Flip it, and then and not F. And here we're from line number 5, and we're using the De Morgan's law. Okay, so each steps we're gonna label, okay, which line we get this from and what rule we're using. And then next, well, not is just that thing, right? So not cancel. So not is just R and F. And this is from line 6, and we use the not equivalent. Okay, now see we get a not S. So because we have not S, then we have not S and not L. Right? We have not S, so we have not S and not L. And then here, this is from 4. Oops, sorry. 7 and 8. This is line number 8 from 4, and here is addition. Right? Not S is happening, so not S or not L is happening. Okay, nice. See, we get this guy is happening, so implies R and F. Okay, and this is from line number 7 and 8, and this is modus ponens. Okay, P implies Q, P is true, so Q is also true. Okay, R and F, almost there. R and F implies R. Okay, and this is from number 9, and what we're using simplification. Okay, if R and F are happening, so R is happening. Okay, so and then this is how we get the conclusion. Yeah, here, this is a longer example. The previous example, we only have 1 or 2 steps, but here we have a lot of steps. Okay, but it's okay. We're gonna look at the letter, okay, group the lines with the letter and try to relate them together. And then from the longer one, you see we didn't have not as, so how do we create not as? Well, think about the contrapositive, and then the not is outside of the parentheses, so we want to move it in. How do we move it in? Use the De Morgan's law, and then we can use modus ponens to get the conclusions. And when you have the and or, think about addition, summification, disjunction, conjunctions. Okay. Alright, so this is session 1.4. If you have any questions, feel free to print screen and ask me. Have a nice day. Bye.